What do we want to look at here from these problems?
23 in the book and 26.
23 in the book and 26. Is 23 in the book, is that the swimming pool?
26.
26 is the swimming pool. So those two in the book. Okay. So 26 is the swimming pool. So 23. All right, 23. Is that the one with the ratio of the height to the radius? Okay. Okay. So 23. They want to find they want you to find this ratio right here. Right. Okay. So coffee filter has the shape of an inverted cone. Okay. So we're looking at this kind of a thing here. And it says now water drains out at 10 cubic centimeters. So what would that be? That'd be V prime. So V prime would be negative 10, right? It would have to be negative 10. Okay. Drains out of the cone at 10 cubic centimeters per minute. When the depth of the water in the cone is 8 centimeters, so we have water in here. So the depth or the height we could say is 8. The depth is decreasing, so that would be what? H prime is decreasing at a rate of 2. What is the ratio of the height of the cone to its radius? Okay, so what's your question about this? I'm sure where to start, right? Well, I mean, the starting point would be, I mean, and maybe you did that, right, is to write this, right? Because we got a cone, we got the volume of the water in the cone is that, the volume of the cone is that. And what this problem does is kind of turns it in reverse the way we normally do the cone, right? The key thing we said yesterday to the cone problem is we always know the cone, if we know the size of the cone, then the water is going to be in that ratio. So there's going to be the ratio of the height to the radius. Here's the key, and this is what most people never think of on this problem, and that is what they're asking you to find, the ratio of the height to the radius, that's a constant, right? In other words, if I have a cone, if I have a cone that has, say this is 8 and the radius is 4, then the ratio of the height to the radius, 8 over 4, that's 2. It will be, so no matter where the water level is in here, if this is 6, then this has to be 3. Right? And if this is 7, this has to be 3.5. It's always going to be in that ratio 2. It's a constant. So the secret to this problem is saying, okay, let's just call this K, this thing we're trying to find, right? Because the problem is we don't want to do the derivative with this volume equation because we get R primes and H primes and we don't have any R primes and all that, right? So we have to make variables. Right? H and R are both vary, but their ratio is a constant. So by doing that, that allows us to now multiply to get H equals RK, and then divide by K. R would equal H over K. Now do you see the nice thing about that? Because that's just a constant. So now we can take this and we can substitute it right there. So let's go through that. Let's see what happens. So we get V equals 1/3 pi. In place of R, we put H over K squared times H. And so we would get V equals, now we would have H squared on top, we'd have H, that'd be H cubed, we'd have K squared on the bottom with this 3. So we'd have 1 over 3K squared pi H cubed, right? But that's okay now because the R, before the R was a variable, we've replaced that then with a K that's a constant. And see, then we're not going to get a K prime, for example, right? So now what? Now you do your derivative. So you got V prime equals, and then the 1/3 squared times pi. I could put that pi on top, actually. And actually, if I bring the 3 down in front, that 3 would actually go there. It would cancel that 3. And then I'd get h squared h prime, correct? Let's bring the 3 there. That would cancel that 3 in. Okay, now I can plug in all my stuff. Now I can plug all my stuff, and I think I've got everything but k, right? So v prime is -10. I've got pi over k squared. H squared is -2. That would be 4. And h prime, oh no, I did that wrong. H is 8. So that would be 64. And h prime is -2. So now I just got to solve that for k. K is positive, so we're in the square root. What do you get?
6.24.
Really? Okay.
Yeah, 6.3.
And that's what we wanted, right? We're done. I mean, that is the ratio of the height to the radius. So most cone problems, you know the ratio of the height to the radius, and then you set that up, and that lets you substitute your R out. Here, we didn't know what the ratio of the height to the radius was, so we just called it a constant. Okay, so that was not number 28, that wasn't. That was 23. Okay, 23. All right. Swimming pool, number 26. Okay, let's talk about that. Okay, so now I've redrawn it, you know, and that's probably the hardest part of this one is getting. Matter of fact, that's why I drew this ahead of time. I drew this a number of years ago because I got tired of drawing it every year because I couldn't draw it very good, and I made it. It's not really to scale. This is 7. This is 3, but I wanted to make sure we understood this. So let's write down what they told us. So in 26, they say, so I've got my 15, this is 10 deep, so, but 3 of it is this part, 7 of it is this bottom section. Water's being added at a rate of 25 cubic feet per minute. So what's that? That's V prime. So V prime is 25. Okay, so V prime is 25. And that's really all they tell us. Then they say, how fast is the water level rising when there's 2,000 cubic feet of water in the pool? So that'd be V, right? V would be 2,000, okay? And then 3,000. So we'll do it with 2,000 first. So we need the volume. So obviously we need the volume. And they want to know how fast the water level is rising. So let's call that H prime. That's what we're looking for, right? Now, the key is where's the water level? So let's understand this. So as the water rises, what's going to happen in the earth when you first start putting water in? What's going to happen? When's the water level rising fast or slow or whatever? I think so. Because you're pouring this water in, it's going up a little bit, but it's mostly going this way, right? But now as it goes up, it's starting to spread, right? It's starting to spread. So it's slowing down, slowing down, slowing down. Now what happens once it gets to here? It's going to be constant the rest of the time, right? Because you're putting it in at a constant 25 cubic feet per minute. So once it gets into this upper section, it's just going to be rising at a constant rate the rest of the time. So the key is we need to know how much water is down in this bottom section, right? Are we in the bottom section or are we in the top section, right? So we need to know the volume of that bottom section. So what's the volume of the bottom section? The red, let's do that. What's the volume of a triangular wedge like this? That's exactly right. It's the area of the triangle, which is a 1/2 base times height, and then times the 15. Okay? So what is that? 2100. So when there's 2,000 cubic feet in there, the water is down in this section. Okay, so I'm going to draw that water down there. So the water is right down here. Okay. So we've got water that is down. So the water is filling up, but it's right in here right now. Right? So here's our H. So there's our H. And then what about this distance here? Right? We don't know what that is either, right? So let's call that, I don't know, call that X, I guess, or something. Okay? But we do know it's 15 back here, right? We know that's 15 still across there. So what is the volume then of the blue? So that'd be what? 15 halves H X, right? So 1/2 times H times X times 15 would be the volume of the blue, right? So we've kind of got this extra variable in here, right? Because we want H prime, we got V prime, V, so we want to get V and H in here, but we don't really want the X. But don't we have a similar triangle situation? Look at the red. Look at the blue. What's that ratio? Well, H over X would equal what? Yes. H over X would equal 7 over 40. So we would get 7X equals 40H. X would equal 47H. So now we can substitute that. So we get V equals 15 halves times H times 47H. So that would simplify to, we cancel, you do that in your calculator too. So that would cancel to 307H squared. Would that be true? And now what? V prime would equal 607 H prime, right? Bring the 2 down in front. We would have that. And then we got everything we need. Our V prime is 25. Our H, oh no, we don't have everything. We need an H yet. And then we got our H prime. How would we get our H? Right? When there's 2,000 cubic feet here, we should know that high. So let's solve that. So 2,000 equals 307 H squared. Solve that. .831. Okay, and then now we can solve for our H prime. So 0.043 feet. But you'd expect it to be going pretty slow. it's only going in 25 cubic feet per minute. So you got 2,000 cubic feet in there, so it's not going up real fast. Now, what about 3,000? That should actually be easy, right? Because to be honest, we don't even have to worry about what's down here. We only really have to worry about what's up here, right? So when there's 3,000 cubic feet in there, we're up here. So we could just call this H. Now we know this is 40, right? So we've eliminated that X variable altogether. And we got 15. So our volume now is 40 times 15 times H. Right? So what is that? 600 H. So V prime would be 600 H prime, wouldn't it? I feel like I'm missing something, but I don't think so. It'd just be 40. I think that's it, right? So 25. So we don't even need the 3,000 and figure out how high it is. We don't even need H. So 25 equals 600 H prime. So what's 25 divided by 600? 0.04. So 2. So almost the same. Now remember, we said it was 2,100 up to here. So at 2,000, we're almost up to there. So it's not surprising it's about the same. It's a little slower. So it's getting slower, 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 slower. 0.043, then it gets to here, it's 0.042, and then it just stays 0.042. Those would definitely be on the hard, you know, a homework problem or a quiz problem for sure. You know, probably even harder, too hard, you know. And most, I mean, obviously, you know, there's what we need to be able to do, what we need to be able to learn, what we need to be able to work on, and then there's what we'll put on the quiz, right? And so, we want to be able to do the basics of what is on the quiz. But, okay. What about the business packet? Anything there? What, I forget what those two problems were. 21 was a lot like the other ones we've been doing.
You just had to like do the coordinates, right?
I think that's the easiest way on this one with the 25. Since it's not dropping by 1, you know, it makes that slow point. So I think if you do number of units X, so if you had 300 units, it's $40 price. If you have 275 units, it's a $45 price. So your slope is basically going to be -5 over 25, which would be -1/5. So you're looking at your price equation being -1/5, and then X minus 300 plus 40, right? So to me, that's your equation, right? You got -5, and then I think you put the wrong things on, because X should be the units. X is the units, and so your price is your Y. So I think, what did you get for, did you Matt? Did you look at the answer sheet that I had? Okay, so if I distribute this, let's just go through this here. If I distribute this, so this would be P equals -1/5 X plus 100. So that'd be my price equation, right? Then my profit would be X times that, or my revenue. So my revenue would be X times that, so -1/5 X squared plus 100X minus, and what's my cost? Oh, no, we're not getting into profit, we're just doing revenue. So this would be revenue, so that's my revenue, right? So what is my maximum revenue? So I just need the derivative of that. So that'd be -2/5 X plus 100 equals 0. So -2/5 X equals -100. So -2X equals -500. So X equals 250. But that's not what they wanted. They wanted the price per unit. So you put that back into this. So that would be -1/5 times 250 is -50 plus 100, that'd be 50. So your price would be, is that what you,
I had second,
you had it flipped, yeah. See, so, yeah, X is always the number of units, and then the price, the P, is the demand function. It says assuming the demand function is linear, okay, which is what we assume that with that. So that demand function, of course, is your price. So $50. So a couple of price increases seems to give us the max revenue. And then the power line one, that was pretty much like that snowmobile problem, right? I mean, that's just a matter of now we're gonna run here, and we're gonna run here. And it was more underwater, so this is $8 a foot. So you got 0.5 squared plus X squared, square root of that, times $8 a foot, right? So that'd be that, plus, so that's your cost, okay? So this is your cost, would be that plus 6 minus X times $6 a foot, right? So that would be the cost. Now it says graph it, but I would just say let's do it the same way we're doing it. They would graph it, whatever. I guess I didn't say that yesterday. I would give you this problem as just a regular problem. We would want to minimize the cost, right? So we would want to just take that, do C prime, set it to 0, okay. That's kind of what they would tell an Algebra 2 class, you know, go ahead and graph that cost, trace, and find your minimum. So, all right, so let me see what. All right, well, I would say we'll just go ahead and work on the Anton. Okay, so the Anton packet, you've got the first 2 pages here. Now, I will say on the first question here on the Anton packet. Now, keep in mind that I took this out of a textbook where, so number 1 would be like, they're assuming this is the very first problem that these students have worked on related rates, you know what I mean? So we got A, B, C, and D, they're breaking it down. So it says let A be the area of the square whose sides have length X and assume X varies with time T. So, you know, so they're saying, okay, draw a picture. So step 1, draw a picture. Step 2, write an equation that relates the area. It's okay, A equals X squared. Okay, find the equation that relates A prime and X prime. Well, that'd be A prime equals 2X, X prime. You know what I mean? So they're just, all they're doing is leading you through the problem. And then the real problem is that, at a certain instant, how fast is the area increasing? So just understand that's what's going on. Now, feel free to jump around here. So the first 2 pages are about related rates, okay? Then the next 3 pages, it says exercise 6.2. Now these get into the max min. So you want to do a few of the related rate problems and then jump over and do a few of the max min problems. You know, feel free to do that in whatever order, right, you want to do that. Okay, so we'll just have some work time, and I've got the answers. I'll put those up on the website. I've got them up there already. It's like under Friday. Is today Friday the 13th? It is Friday. Yeah. So I've got the answers there if you need to pull those up. Okay.